In this video, I'll be explaining you about the meaning of LCM, that is least common multiple of a given set of numbers, and also how to find the least common multiple of a given set of numbers using various methods. Before we begin with the methods, first let us understand the meaning of least common multiple of a given set of numbers through an example. Let me take two numbers, say 15 and 20. What are multiples of the number 15? A number is said to be a multiple of 15 if and only if it can be written as 15 times another number or 15 into another number. Such numbers are called multiples of 15. For example, the number 15 itself is a multiple of 15 because 15 can be written as 15 into 1. Next number 30 is also a multiple of 15 because 30 can be written as 15 into 2. Next 45 is a multiple of 15 because 45 can be written as 15 into 3. Next we have 60 because 60 can be written as 15 into 4. Then 75, 90, 105, 120 and so on, because 120 can be written as 15 into 8. 105 can be written as 15 into 7. 90 can be written as 15 into 6. 75 can be written as 15 into 5. You can continue in this way. Now let us write the multiples of the number 20. The number 20 itself is a multiple of 20 because 20 can be written as 20 into 1. Next we have 40 because 40 can be written as 20 into 2. Next we have 60. 60 can be written as 20 into 3. Then we have 80, 100, 120, 140 and so on. We can continue in this way. So these are some of the multiples of the number 15 and these are some of the multiples of the number 20. Now let us identify the common multiples of 15 and 20. Now this number 15 is a multiple of 15 but it is not a multiple of 20. Therefore 15 is not a common multiple. Next we'll go to 30. 30 is a multiple of 15 but it is not a multiple of 20. Therefore it is not a common multiple. Next 45 is a multiple of 15 but not 20. 60 is a multiple of 15 as well as the number 20 because 60 can be written as 15 into 4 and the same number 60 can be written as 20 into 3. Therefore 60 is a common multiple of 15 and 20. So let us circle 60. Next 75 is a multiple of 15 but it is not a multiple of 20. 90 is a multiple of 15 but not 20. 105 is a multiple of 15 but not 20. 120 is a multiple of 15 as well as the number 20 because 120 can be written as 20 into 6 and the same number 120 can be written as 15 into 8. Therefore 120 is also a common multiple of 15 and 20. Now let us list out all the common multiples. So common multiples of 15 and 20. So we'll start with the least number. 60 is the first common multiple. Next 120 is the next common multiple. The next common multiple will be 180 and so on. So let me put dot dot dot. Now the least number of this common multiple set will be our LCM. So the least number of this set will be our LCM. So therefore LCM of 15 and 20 is 60. There are two methods to find the LCM of a given set of numbers. The first method is prime factorization method. And the second method is common division method. First, let us understand prime factorization method. Let us consider the same example, the numbers 15 and 20. The first thing that you need to do in prime factorization method is to consider the numbers separately. First, let me consider the number 15. Next, you need to identify the least prime number that divides 15. 2 doesn't divide 15. 3 is the next prime number. 3 divides 15, that is 3 5s are 15. We cannot continue with the number 3 because 3 doesn't divide 5. Therefore, we need to look for another prime number. Next is 5. So 5 divides 5. 5 ones are 5. We will do the same thing for the number 20. So the first prime number is 2. 2 divides 20. 2 tens are 20. We can still continue with 2 because 2 divides 10. 2 fives are 10. We cannot continue with the number 2 because 2 doesn't divide 5. Next number is 3. 3 also doesn't divide 5. Next prime number is 5. 5 divides 5. 5 ones are. After doing this, we need to write the numbers 15 and 20 in terms of the product of their distinct prime factors. First, let us write for the number 15. 15 can be written as 3 into 5 because 3 and 5 are the prime factors of 15. Next is 20. 20 can be written as 2 into 2 into 5. These are the prime factors. 2 into 2 into 5 gives us 20. So 2 into 2 into 5. And this can be written as 2 square into 5. After doing this, we need to identify all the distinct prime factors that are occurring in the prime factorization of both 15 and the number 20. Now we have 3, 5, here 2 and 5. So these are the distinct prime factors that are occurring in the prime factorization of both 15 and 20. So let us write down the distinct prime factors are, so the distinct prime factors are 2, 3 and 5. So these are the three distinct prime factors that are occurring in the prime factorization of 15 as well as 20. Here we have 3 and 5, we have considered both 3 as well as 5, and here we have 2 and 5, we have considered 2 and 5 is already considered here. These are the three distinct prime factors. Now we need to identify the highest power of each distinct prime in the prime factorization of 15 and 20. Now first let's start with the number 2, first prime number. So the highest power of 2 is 2. As you can see here, 2 is here and the highest power of 2 is 2. Now let us write down 2 square into the next prime factor is 3. So next prime factor is 3 and we have 3 here and the highest power of 3 is 1. Therefore, we will write 3 to the power 1 into the last distinct prime number, that is 5, and here we have 5 to the power 1, here also 5 to the power 1. So the highest power of 5 is 1. Therefore, let us write 5 to the power 1. When we multiply all these three terms, 2 square into 3 to the power 1 into 5 to the power 1, and that will give us 60. This is the LCM of 15 and 20. Now we will take one more example and find the LCM using prime factorization method. Let me take three numbers now, 40, 45 and 26. Now let us find the LCM of these three numbers using prime factorization method. Like I said before, the first thing that we need to do in prime factorization method is to consider the numbers separately. First, let me consider the number 40. So we need to identify the least prime number that divides 40. So 2 is the least prime number that divides 40. 2 20s are 40. 2 divides 20, therefore we can continue with the number 2. So 2 tens are 20. We can still continue with the prime number 2 because 2 divides 10. So 2 fives are 10. We cannot continue further with 2 because 2 doesn't divide 5. Therefore, we need to look for another prime number. Next prime number is 3. 3 doesn't divide 5. Therefore, we need to consider the next prime number, that is 5. 5 ones are 5. We need to do the same thing for the remaining two numbers. So let's continue with 45. 2 doesn't divide 45. 3 is the next prime number. 3 divides 45. 3 15s are 45. So we'll start with the prime number 3. 3 15s are 45. The prime number 3 still divides 15. Therefore, we can continue with the number 3. 3 5s are 15. We cannot continue further with the number 3 because 3 doesn't divide 5. Therefore, we need to look for the next prime number. The next prime number is 5 and 5 divides 5. 5 ones are 5. Let us do the same thing for the last number, that is 26. 2 is the first prime number that divides 26. So 2 13s are 26. Since 13 is a prime number, no prime number less than 13 will divide 13. Therefore, we need to start with the number 13 itself. 13 ones are 13. Now we need to write down the numbers 40, 45 and 26 in terms of the product of their distinct prime factors. So let us write for 40 first. So 40 can be written as, these are the prime factors of the number 40. So 2 into 2 into 2 into 5, that is the product of these four numbers, 2 into 2 into 2 into 5. And the next number 45 can be written as 3 into 3 into 5, 3 into 3 into 5. The last number 26 can be written as 2 into 13. Therefore, let us write 2 into 13. This number can be written as 2 to the power 3 into 5, and 45 can be written as 3 square into 5, and the last number is written as 2 into 13 itself. Now we need to identify all the distinct prime factors that are occurring in the prime factorizations of 40, 45 and 26. These are the prime factorizations of 40, 45 and 26. Now let us write down the distinct prime numbers. Distinct prime factors are, so the distinct prime factors are, we have 2, then 3, 5 and 13. So these are the four distinct prime factors that are occurring in the prime factorizations of 40, 45 and 26. So we have 2 here, 3 here, 5 here and 13 here, and this 2 is already considered because every prime factor is considered only once, and this 5 is already considered. Therefore, these are the four distinct prime factors that are occurring in the prime factorizations of 40, 45 and 26. Now we need to identify the highest power of these distinct prime factors in the factorizations of 40, 45 and 26. Let us begin with the first distinct prime factor, that is 2. The highest power of 2 in the prime factorizations of 40, 45 and 26 is 3. Here we have 2, the power of 2 is 1, but here we have another 2, but power of 2 is 3. Therefore, the highest power of 2 in the factorizations of 40, 45 and 26 is 3. Let us write 2 to the power 3 into, let's go to the next distinct prime factor, that is 3. We have 3 here, the highest power of 3 is 2. Therefore, let us write 3 to the power 2 into the next prime factor, that is 5, and we have 5 here and one more 5 here, and the power of 5 is 1, and here also it is 1. Therefore, the highest power of 5 is 1 into the last prime factor, that is 13, and we have 13 here and the power of 13 is 1, and therefore the highest power of 13 is 1. Therefore, let us write 13 to the power 1. When you multiply all these four numbers, that is 2 to the power 3 into 2 to the power 2 into now now when we multiply all these four terms, that is 2 to the power 3 into 3 to the power 2 into 5 to the power 1 into 13 to the power 1, we get a number, and that will be our LCM. Therefore, the LCM is 4680. This is the LCM of 40, 45 and 26. Now we will go to the second method, that is common division method. We will consider the same two examples and let's see how this common division method works and helps us in getting the LCM of a given set of numbers. Let me consider 15 and 20. The first thing that you need to do in common division method is to list out all the given numbers in the set horizontally like this. And then you need to identify the first or the least prime number that divides at least one of the given numbers. We have two numbers here, 15 and 20, and we need to identify the first or the least prime number that divides at least one of these two, either 15 or 20. Now we have 2 as the least prime number. 2 definitely divides 20 because 2 into 10 gives us 20. Therefore, we will begin with the least prime number 2. 2 doesn't divide 15, therefore 15 is written as it is. Next, 2 divides 20, 2 tens are 20. We can continue this division process further with the prime number 2 because 2 still divides the number 10. Therefore, it divides at least one of the numbers. We will continue with 2. 2 doesn't divide 15, therefore 15 is written as it is. 2 divides 10, 2 5s are 10. Next, we cannot continue further with the prime number 2 because 2 doesn't divide 15 as well as the number 5. Therefore, we need to look for the next prime number. The next prime number is 3 and 3 divides 15 but 3 doesn't divide 5. That is okay because we need to find the prime number that divides at least one of the numbers. Now, 3 5s are 15. 3 doesn't divide 5, therefore 5 is written as it is. We cannot continue with this division process with 3 because 3 doesn't divide 5. Therefore, we need to look for the next prime number, and the next prime number is 5. 5 ones are 5 ones are. After doing this, we need to multiply all these prime numbers. When we multiply all these prime numbers, we get a number and that will be our LCM. Therefore, the LCM is the LCM of 15 and 20 is 2 into 2 into 3 into 5. That is 2 2s are 4, 4 3s are 12, 12 5s are 60. So 60 is the LCM of 15 and 20. Now we will take the second example. 40, 45 and 26. Now let us find the LCM of these three numbers using common division method. The first thing that we need to do in common division method, like I said before, we need to list out all the numbers given horizontally. So 40, 45 and 46. Then we need to identify the least or the first prime number that divides at least one of the given numbers. Now we have three numbers here, 40, 45 and 26. we need to identify the least prime number that divides at least one of these three numbers. Definitely 2 divides 40 and 2 divides 26. Therefore, 2 divides at least one of these three numbers. Therefore, we can begin with the prime number 2. So, 2 20s are 40. 2 doesn't divide 45. Therefore, 45 is written as it is. 2 divides 26. 2 13s are 26. We can continue this process with the prime number 2 because 2 divides 20. Therefore, 2 divides at least one of these three numbers. So, 2 tens are 20. 2 doesn't divide 45, therefore 45 is written as it is. 2 doesn't divide 13, therefore 13 is written as it is. We can continue the process further with the prime number 2 because 2 still divides the number 10. Therefore, 2 divides at least one of the three numbers. 2 5s are 10. 2 doesn't divide 45, therefore 45 is written as it is. 2 doesn't divide 13, therefore 13 is written as it is. Now we cannot continue this process further with the prime number 2 because 2 doesn't divide 5, doesn't divide 45 and 2 doesn't divide 13 also. Therefore, we need to look for the next prime number. The next prime number is 3. 3 divides 45, that is 3 15s are 45. Therefore, 3 divides at least one of these three numbers. So, we can start with the prime number 3. 3 doesn't divide 5, therefore 5 is written as it is. 3 divides 45, that is 3 15s are. 3 doesn't divide 13, therefore 13 is written as it is. We can still continue this division process with prime number 3 because 3 divides 15. Therefore, 3 divides at least one of these three numbers. So, we can continue with 3. 3 doesn't divide 5, therefore 5 is written as it is. 3 divides 15, that is 3 5s are. 3 doesn't divide 13, therefore 13 is written as it is. Now we cannot continue this process further with the prime number 3 because 3 doesn't divide 5, 5 and 13. Therefore, we need to look for the next prime number. The next prime number is 5. So, let us continue the process with 5. 5 ones are 5 ones are. 5 doesn't divide 13, therefore 13 is written as it is. Since 13 is a prime number, we need to consider 13 and continue the process. 13 doesn't divide 1, so 1 is written as it is. 1 is written as it is. 13 divides 13, 13 ones are. So we need to stop this process when we get 1 for all the numbers. The next step is to multiply all these prime numbers. When we multiply all these prime numbers, we get a number and that will be our LCM. Therefore, the LCM of 40, 45 and 26 is LCM of 40, 45 and 26 is 2 into 2 into 2 into 3 into 3 into 5 into 13. That is nothing but 2 to the power 3 into 3 to the power 2 into 5 into 13, that is equal to 4680. This is the LCM of the three numbers.